Balancing equations. Equations tell us what reactants we start off with, what products we produce. But to be able to do calculations with them, decide how much reactants to mix together, how much products we're going to get out, we need to balance the equation first. Balance equation is to ensure that we do not appear to create or destroy matter along the way. So we have to have the same number of each atom on both sides of the reaction. So we're just going to go back and forth, balance each element, and repeat this process until the whole equation is balanced. We do have to be careful that we can unbalance the previous element as we're going along. So we want to verify at the end that we have balanced everything successfully. We have one calcium on the reactant side, one calcium on the product side. That's good. We have one silicon on the reactant side, one silicon on the product side. We have 3 oxygens on the reactant side, 1 oxygen on the product side. So to balance the reaction, we do not want to change any subscripts. Our first step actually is to verify we have everything written correctly and the subscripts are good. So we do not want to touch the subscripts now. So all we're going to do is put coefficients in front of the compound. So this is saying that we're producing 3 water molecules. So we're going to count each element by the coefficient times the subscript, and that oxygen has an implied 1. So we have 3 oxygens now to match the 3 oxygens on the reactant side. We have 1 hydrogen. Now we have 3 times 2 or 6 hydrogens. So to get 6 hydrogens over here, we add 6 coefficient in front of the hydrogen fluoride. We have 6 fluorines. The coefficient multiplies everything in the compound. We have 6 fluorines. And we have 2 plus 4 is 6 fluorines. So we went through it once. Now we just verify. We should verify that it's completely balanced. So I have 1 calcium both sides, 1 silicon both sides, 3 oxygen both sides, 6 hydrogens, and 6 fluorines. So this is a good balanced equation. And the ratio here, the coefficients are molar ratios. So this means that we have a mole of calcium silicate reacting with 6 moles of hydrogen fluoride to produce 1 mole of calcium fluoride, 1 mole of silicon tetrafluoride, and 3 moles of water. And of course, to convert moles into grams, we need the molecular weights or molar masses of the compound. So to get the molar mass of a compound, what we're going to do is we're going to look up the atomic masses on the periodic table and then add them up for all the elements present. So we have 1 barium, barium to 2 decimal places, which is, I would prefer at least 2 decimal places on molar masses. So that would be 137.33. And sulfur will be 32.07. Oxygen to 2 decimal places is 16.00. But we have 3 oxygens, so we multiply this by 3. Now we just add these all together, and we end up with 217.40. And we get our choice. We can do either AMU, atomic mass units, or if we're going to be converting between moles and mass, our units wants to be grams per mole. So these units are interchangeable based on how we define them.